Okay, so we'll be looking at separation techniques, continuing on separation techniques. So we'll look at three of them. We'll briefly describe them: crystallization, centrifugation, and chromatography. So we'll take the first one, crystallization. Now, we looked at evaporation to dryness as one of the separation techniques, and we saw how it is used to separate solutes from solution. That is for evaporation to dryness. We saw how it's used to separate solutes from solution. Now, there are some solutes actually that decompose on heating. They cannot withstand the amount of heat that is usually applied in evaporation to dryness as a separation technique. Those solutes, whenever so much heat is applied to them, they decompose or they are destroyed. So for that reason, this separation technique, crystallization, is used. Now, like I said, it's also used to separate solutes from their solution, but solutes that decompose on heating. So that is the major difference. Now, the process is actually quite different, or not too different per se, from evaporation to dryness. In crystallization, what happens is that the solution is heated. Okay, it's heated to a point where the moisture, the water content evaporates up to an extent. And when it evaporates up to an extent, it is then allowed to cool. Okay, what is left is allowed to cool. Now, of course, if let's say you had 200 ml of water, okay, let's say you had 200 ml of water in there, and that 200 ml of water in the solution was heated, and that 200 ml of water evaporated until what you have left is, let's say, 20 ml of water. Okay, so you find out that you still have the same amount of solutes that you had, but you have less solvent. So the solution is much more concentrated, right? After you heated it, it's much more concentrated. So when you now allow it to cool, okay, what happens is that crystals of the solute, or that salt you are trying to separate, begins to form, and then it is collected. Okay, so that is what crystallization is all about, or how crystallization is carried out. Now, like I said, the difference between this and evaporation to dryness is that you do not use as much heat as you would use during evaporation to dryness as you use during crystallization, and you do not completely allow the solution to dry up such that you have the solute alone, because the salts or solutes that are separated using crystallization are solutes or salts that decompose when they are heated at very high temperatures. So another thing to note is that at the end of crystallization, the salt will still contain some amount of water in it, which they refer to as water of crystallization. Water of crystallization. Okay, so you can see a salt like copper 2 tetraoxosulfate 6 pentahydrate. Copper 2 tetraoxosulfate 6 pentahydrate. Okay, so this pentahydrate in the chemical formula will be represented by 5H2, that's 5 moles of water, okay, representing the water of crystallization. Okay, so that is what happens during crystallization. That briefly summarizes what happens during crystallization. Now, the second we have here is centrifugation. Now, centrifugation is a separation technique that is that makes use of a special apparatus known as a centrifuge. Makes use of a special apparatus known as the centrifuge. Now, this centrifuge is, the way it is designed, is capable of holding test it's just above the level of the mobile phase. You know, if you dip this now, it's touching the liquid phase, right? So the spot of ink that you want to separate is placed on the stationary phase on the paper, and then it's lower just above the level of the mobile phase. You understand? Now what happens is that as you put the stationary phase with your mixture you want to separate within like this, the solvent or the mobile phase will start ascending upwards. You understand? It's as if it will start soaking. You understand? And as it's soaking, it's gradually soaking upwards. Okay? So it begins to move up, soaks the stationary phase. Then when it touches and immerses this, what you want to separate, it continues on moving upwards. Then as it moves upwards, it starts separating it, till it gets to a point where it has finished separating all the constituents, and then you won't see any other anything there again. So with that result, you can actually analyze how many components. Okay, you look at the progression, the way it's separated, and you know how many components the mixture or the solvent you wanted to separate.
For this chromatography, unlike certification or presentation, you can't get the solvent back. For
this, yeah, that is a mixture,
yeah.
Right? Yeah, you can't actually. The once it's separated, it's okay. So, any other questions?